အကယ်၍သင်ဟာ AI enthusiast သို့မဟုတ်ကျောင်းသားကျောင်းသူတစ်ဦးဖြစ်နေခဲ့မယ်ဆိုလို့ရှိရင်အခုချိန်မှာ AI ကို blackbox အနေနဲ့မမြင်သင့်တော့ပါဘူး။ဒီဗီဒီယိုမှာ neural network တွေရဲ့ forward pass အကြောင်းကိုရှင်းပြပေးသွားမှာဖြစ်ပါတယ်။ Okay, so what we are seeing right now is the basic building block of artificial neural network called artificial neuron with an input X. And there is an output coming out from the artificial neuron at the end. And the number between X and the neuron A is something called the weight, and it is denoted using Greek letter called omega. And we also have the bias term for each neuron in artificial neural network. One thing to note here is that the input X is denoted using lowercase letter x. And we are going to find the result of neuron A. In order to do that, we need to activate a neuron A using the activation function or the step function. Before applying the activation function to the neuron, we need to calculate the value of z using the following formula. Z is equal to omega x plus b. Suppose we have the input value of 1, the weight omega value is also 1, bias term is 0, and also the activation function, which in this case is the linear function 2z. Then according to z is equal to omega x plus b, we're going to have 1 into 1 plus 0 equals to 1. And now we can apply the activation function to obtain the value of neuron A. In this case, the value is 2. Okay, so this is our first example of getting the value of neuron with single input. Now we can see there are two inputs in this example, and we are going to find the value of neuron A. Since we have two inputs, we now also have their two corresponding weights, and we are interested in the value of neuron A. To do that, we need to apply the activation function to the neuron A. For simplicity, we change the notation of two inputs into x1 and x2. First, let's find the value of z. Because we have two inputs and they are corresponding to weights, we have to modify our formula to calculate z. Now it becomes omega 1 x1 plus omega 2 x2 plus b. And now suppose we have x1 is equal to 1, x2 is equal to minus 1, omega 1 is equal to 1, omega 2 is equal to 2, bias is 0, and we also have activation function of z squared. Notice we have nonlinear activation function here. Okay, now according to the new formula we have, we can calculate the value for z, which in this case is minus 1. Now we are going to apply the activation function, and the final answer is 1, which is also the result of neuron A. So yeah, that's it for example 2. In this example, we are seeing a neural network with two layers. In the first layer, we have two neurons, neuron A and B. In the final layer, we have one neuron, which is neuron C. And there are two inputs going into this neural network, x1 and x2. Their values are 1 and 2 respectively. We apply the same activation function g of c to all three neurons. And we are going to find their values. Let's start by calculating the value of neuron A. Because there are two inputs, x1 and x2, going to the neuron A, we are going to calculate the value of c using the same formula as in the previous example. And what if we have three inputs or more than two inputs? I will leave this to you to think about it yourself. Since we have the value of z, now let's apply the activation function to this value. And here we get the result of neuron A. I encourage you to calculate the result of neuron B and C yourself. Good luck and thank you for watching.